Hello friends, welcome back. In this session you are going to learn about probable error and its significance in finding or in interpreting correlation coefficient. Probable error is a statistical tool which is used to measure the reliability of the value of Karl Pearson's coefficient of correlation insofar as it depends upon the conditions of random sampling. So random sampling, I think you have studied about sampling population etc. in your collection of data chapter. Sampling plays a very important role in collecting the data because when population data is more, you cannot collect all the data related to whole population. Therefore, sampling is used as a measure to collect the data, and on that basis inferences will be made, conclusions will be made about the total population. In such a case, there may be some errors. The surveyors or the persons involved in collecting the data may commit some errors while collecting the samples, or the collected samples themselves may pose some limitations while concluding about the population. So such errors must be accounted for while inferring or while deciding about the population parameters. Okay, in that sense, while calculating correlation coefficient, probable error plays a very important role in measuring the reliability, that is dependability of correlation coefficient for taking any decisions. ನಿಮಗೆ correlation coefficient ನಂಬಬಹುದೇ? ಯಾವುದೋ ಒಂದು ಫಿಗರ್ ಕೊಡುತ್ತೆ, ಈಗ ಹೈ ಡಿಗ್ರಿ ಪಾಸಿಟಿವ್ ಕಾರ್ರಿಲೇಷನ್ ಅಂತ ಹೇಳ್ತೀವಿ ಅಥವಾ ಹೈ ಡಿಗ್ರಿ ನೆಗೆಟಿವ್ ಕಾರ್ರಿಲೇಷನ್ ಅಂತ ಹೇಳ್ತೀವಿ. ಆ ಒಂದು ಹೈ ಡಿಗ್ರಿ ಕಾರ್ರಿಲೇಷನ್ ಅನ್ನ ಅಥವಾ ಲೋ ಡಿಗ್ರಿ ಕಾರ್ರಿಲೇಷನ್ ಯಾವುದೇ ಒಂದು ಆನ್ಸರ್ ಅನ್ನ ಇಂಟರ್ಪ್ರಿಟೇಷನ್ ಅನ್ನ ನಾವು ನಂಬಬಹುದೇ ಅಂತೇಳಿ ತಿಳಿಯೋದಿಕ್ಕೆ ನಾವು ಪ್ರಾಬಬಲ್ ಎರರ್ ಅನ್ನೋ ಒಂದು ಟೆಕ್ನಿಕ್ ಅನ್ನ ಬಳಸ್ತೀವಿ ಅಂತ ಹೇಳಿ. ಯಾಕಿದು ಅಂತಂದ್ರೆ, ಈ ಒಂದು ಪ್ರಾಬಬಲ್ ಎರರ್ ಅನ್ನ ಕಾರ್ರಿಲೇಷನ್ಗೆ ಆಡ್ ಮಾಡೋದ್ರ ಮುಖಾಂತರ ಅಥವಾ ಲೆಸ್ ಮಾಡೋದ್ರ ಮುಖಾಂತರ ನಮಗೆ ಎರಡು ಲಿಮಿಟ್ ಬರುತ್ತೆ. We get two limits. When we take up any other sample in the given population itself, the correlation coefficient must be within that lower limit and upper limit. If so, then we can depend upon the correlation coefficient as reliable, valid coefficient of correlation. To measure that reliability, probable error is computed. Okay, let us go in detail about this. According to Horace Sechrist, the probable error of correlation coefficient, that is small r, is an amount which, if added to and subtracted from the average correlation coefficient, produces amounts within which the chances are even that a coefficient of correlation from a series selected at random will fall. Random ಅಂತಂದ್ರೆ ಯಾದೃಚ್ಛಿಕ ಅಂತ ಹೇಳಿ. ಯಾದೃಚ್ಛಿಕ, ಯಾವುದೇ ರೀತಿಯ ಹತೋಟಿ ಅನ್ನ ಇಟ್ಟುಕೊಳ್ಳದೆ, ಯಾವುದೇ ರೀತಿಯ ನಿಯಂತ್ರಣವನ್ನು ಇಟ್ಟುಕೊಳ್ಳದೆ ಕಲೆಕ್ಟ್ ಮಾಡಿರುವಂತಹ ಸ್ಯಾಂಪಲ್ ಒಂದು ಪಾಪ್ಯುಲೇಷನ್. ಈಗ ನಿಮ್ಮಲ್ಲಿ 100 ಜನ ವಿದ್ಯಾರ್ಥಿಗಳಿದ್ದೀರಿ ಅಂತಂದ್ರೆ, ಇಫ್ ಯು ಆರ್ ಇನ್ ಯುವರ್ ಕ್ಲಾಸ್ ದೇರ್ ಆರ್ 100 ಸ್ಟೂಡೆಂಟ್ಸ್, out of which I may select 10 students randomly, means without any control. So I can give like a lottery method, or I can give numbers 1, 2, 3, 4, etc. and I may select the person who got 5, 10, 15, 20 number. 10 numbers will be selected for getting some information from those students. Instead of going through all the 100 persons in your class, I may select 10 students as representative of whole class. So that we call it as sampling. So that sampling, taking that 10 students sample and calculating, say, marks scored in accountancy and marks scored in mathematics or in some other subject. We calculate correlation coefficient, and that correlation coefficient will be applicable to your whole class, 200 students of the class. If similarly, if other 10 members, other 10 samples are selected from your own class, the correlation coefficient computed so should give the same answer, which need not be the correct answer. It may be some variations may be there. So that variation must be within the limit. So that limits will be computed by finding out the probable error. That is the meaning of Weierstrass definition. The probable error of R is an amount which, if added to and subtracted from the average correlation coefficient, produces amounts, we can take it as limits, within which the chances are even, chances are more that a coefficient of correlation from a series selected at random will fall. A correlation coefficient, correlation from a series of other samples selected at random will fall. ಸೊ ಅದೇ ಒಂದು ಲಿಮಿಟ್ ಒಳಗಡೆನೆ ನೀವು 10 ಜನದ ವಿದ್ಯಾರ್ಥಿಗಳ ಮೊದಲು ಮಾರ್ಕ್ಸ್ ಇನ್ ಅಕೌಂಟೆನ್ಸಿ, ಮಾರ್ಕ್ಸ್ ಇನ್ ಸ್ಟಾಟಿಸ್ಟಿಕ್ಸ್ ತಗೊಂಡು ಕ್ಯಾಲ್ಕುಲೇಟ್ ಮಾಡಿ, ಆ 10 ಜನ ಬಿಟ್ಟು ಅಥವಾ ಮತ್ತೊಂದು ಸ್ಯಾಂಪಲ್ ಅನ್ನು, ಇನ್ನೊಂದು 10 ಜನದ ಸ್ಯಾಂಪಲ್ ಅನ್ನು ತಗೊಂಡು ಕ್ಯಾಲ್ಕುಲೇಟ್ ಮಾಡಿದ್ರೆ ಈ ಎರಡೂ ಕಾರ್ಲೇಷನ್ ಕೋಎಫಿಷಿಯಂಟ್ಗಳು ಹತ್ರ ಆ ಒಂದು ಲಿಮಿಟ್ ಒಳಗಡೆನೆ ಇರಬೇಕಾಗತ್ತೆ. ಆವಾಗ ಕಾರ್ಲೇಷನ್ ಕೋಎಫಿಷಿಯಂಟ್ ಅನ್ನು ನಂಬಬಹುದು ಅಥವಾ ಅದರ ಮೇಲೆ ಅವಲಂಬಿತವಾಗಿ ತೀರ್ಮಾನಗಳನ್ನು ಕೈಗೊಳ್ಳಬಹುದು. ಅದನ್ನ ಕಂಡುಹಿಡಿಯೋದಕ್ಕೋಸ್ಕರ ನಮಗೊಂದು ಮೆಷರ್ ಅಂತ ಕೊಡುತ್ತೆ ಪ್ರಾಬಬಲ್ ಎರರ್ ಅಂತ ಹೇಳಿ ಇವರು Weierstrass ಹೇಳಿರೋದು. ವೆಲ್ಡನ್ ಅವರ ಪ್ರಕಾರ ಪ್ರಾಬಬಲ್ ಎರರ್ ಡಿಫೈನ್ಸ್ ದಿ ಲಿಮಿಟ್ above and below the size of the coefficient determined within which there is an equal chance that the coefficient of correlation similarly calculated from other samples will fall. The same meaning is there in Weldon's definition also. You go through it, write down in your notes. It may be there for theoretical question in your examination. Okay, let us go further. The probable error is calculated by using the following formula. PE equals to 0.6745 into, in the numerator, 1 minus R square. R means correlation coefficient square, whole divided by square root of n. Why that 6745? You can remember that 6745. 6 7 6 after 6 7 4 after 4 it is 5. So 6745, 1 minus R square divided by square root of n. Why that 6745? So reason is 6745 is that in a normal distribution 50%, half of the observations lie in the range of, that symbol is called as mu, that is population mean plus or minus 0.6745 standard deviation. This standard deviation is also population standard deviation. So these topics are advanced topics for your level. So we will learn about these things in your higher classes. Please note this. I am explaining, that's all. No, get into your mind why that 6745. There is reason for having that 0.6745. Okay, where mu read as mu is the mean and standard deviation. The sigma is the standard deviation. Okay, so 6745. You don't worry about the details of why 0.6745 etc. You remember this formula, and if problem is given, you use this formula and compute. That's all. Probable error of correlation coefficient is used to determine the limits within which the population correlation coefficient may be expected to fall. So this thing I have already explained. This implies that if we take another random sample of the same size n from the same universe of data, same population data, same I explained in the taking your class. So from your same class from which the first sample was taken, then the new value of correlation coefficient can be expected to fall within the limits of r plus or minus PE. That is, limits are r plus PE and r minus PE. So these are two things you must remember, r plus PE and r minus PE, to find out limits within which the other sample taken from the same universe, same population can lie. So that that may be asked for calculations also in your examination. Please remember r plus PE and r minus PE to find out limits. Okay. Next, if the value of r is more than 6 times, this will be used to interpret the reliability of r, whether it is significant or insignificant. So to find out significancy or insignificancy of correlation coefficient, we have to multiply PE by 6. 6 times the probable error. The existence of correlation is certain, that is significant. That means if r is greater than 6 PE, then r is said to be significant. You must remember this one also. R is greater than 6 PE, then r is said to be significant. Similarly, if the value of r is less than 6 times the probable error, there is no evidence of correlation and r is not at all significant. R is insignificant. That means if r is lesser than 6 PE, then r is said to be not at all significant. It is insignificant. So there is no evidence to rely on the correlation coefficient. So correlation coefficient ಕಂಡುಹಿಡಿದಿರೋದು ನಾವು ಅಷ್ಟಾಗಿ ನಚ್ಕೊಳ್ಳೋ ಹಾಗಿಲ್ಲ, ನಂಬುವ ಹಾಗಿಲ್ಲ ಅಂತೇಳಿ ನಾವು ತೀರ್ಮಾನ ತಗೋಬಹುದು. ಯಾವುದರ ಮೇಲೆ? 6 ಅಂದ್ರೆ ಕಾರ್ರಿಲೇಷನ್ ಕೋಎಫಿಷಿಯಂಟ್ PE ಯ 6 ಪಟ್ಟಿಗಿಂತ ಕಡಿಮೆ ಇದ್ದರೆ, r is less than 6 PE, r is said to be not significant or insignificant. ಅದೇ 6 6 PE ಗಿಂತ ಜಾಸ್ತಿ ಇದ್ದರೆ ಸಿಗ್ನಿಫಿಕೆಂಟ್ ಅಂತ ಹೇಳ್ತೀವಿ, ನಂಬಬಹುದು, ಕಾರ್ರಿಲೇಷನ್ ಕೋಎಫಿಷಿಯಂಟ್ ಇದೆ ಅಂತೇಳಿ, ಅಥವಾ ಏನ್ ಆನ್ಸರ್ ಇದೆ ಕೊಟ್ಟಿರ್ತಾರೆ ಅದನ್ನು ನಂಬಬಹುದು ಅಂತೇಳಿ ನಮಗೆ ತೀರ್ಮಾನ ಕೈಗೊಳ್ಳಬಹುದು. ಓಕೆ, then if this one is additional information for you, you need not remember this. If 0.6745 is omitted from the formula of PE, it results in standard error of R. That is, standard error equals to, see, observe, 0.6745 has been removed, only other part 1 minus r square divided by square root of n is taken to find out standard error. This part you need not worry for your examination point of view. Next, worked problem. If r equals to 0.8243 and n equals to 64, find out the probable error of coefficient of correlation and determine the limits for population correlation. This will be asked for 2 marks. 2 marks are in section B, 6 marks. So you have to apply formula and substitute the values and derive the answer. Therefore, it may be asked for 6 marks also. Okay, let us solve this. Given correlation coefficient 0.8243 and number of pairs of items 64. So let us apply these values into the formula of PE, probable error. Probable error equals to 0.6745 into 1 minus r square whole divided by square root of n. Okay, so 0.6745, it will remain as it is. So 1 minus r square, r means 0.8243, n means 64. Let us substitute this. 1 minus 0.8243 square divided by square root of 64. Let us simplify this. 0.6745 remains same. 1 minus 0.8243 into 0.8243. It will be 1 minus 0.6795. Square root of 64 means 8. Okay, simplify this. 0.6745 will remain same. So 1 minus 0.6795, you deduct it, you will get 0.3205 whole divided by 8. So divide 3205 by 8 and multiply 0.6745. That means 0.6745 into 0.04. Some fractions will be there. I am limiting that to 2 digits only. So 0.04006 something it will be there. So I am taking only 0.04. Multiply this, you will get probable error equals to 0.02702. 2702. Okay, so probable error has been computed. We are asked to determine the limits for population correlation also. So limits are R plus PE and R minus PE. Let us work out it. Limits R plus PE and R minus PE. R is given in the problem 0.8243 plus PE as computed is 0.02702. You must be very careful here. 0.02702 it is. If you have taken 0.2702, answer will be wrong. And R minus 0.8243 minus 0.02702. So add and subtract 85132 and 79728. 0.85132 and 0.79728 are the limits within which other samples, for example, another 64 samples have been taken from the same population. If you computed correlation coefficient among those samples, 64 samples, the answer will be in between 0.85132 and 0.79728. That means lower limit is 79728 and upper limit is 0.85132. Okay, you can also write first say R minus PE and next R plus PE. ನೀವು R minus PE ಅನ್ನು ಫಸ್ಟ್ ಬರ್ಕೊಂಡು R plus PE ಅನ್ನು ನೆಕ್ಸ್ಟ್ ಬರ್ಕೋಬಹುದು. ಅವಾಗ ನಿಮಗೆ ಈ ಲಿಮಿಟ್ಸ್ ಬರೆಯೋದು ಈಸಿ ಆಗುತ್ತೆ. ಓಕೆ, ಗೋಯಿಂಗ್ ಫಾರ್ವರ್ಡ್. ನೆಕ್ಸ್ಟ್ ಪ್ರಾಬ್ಲಮ್, ಟು ಸ್ಟಡಿ ದಿ ಕಾರ್ರಿಲೇಷನ್ ಬಿಟ್ವೀನ್ ದ weights and heights of students of a school. A sample of 100 students is taken from the entire school. The sample gave coefficient of correlation as 7625. Within what limits does it hold good for the entire school? Out of so many students in a school, only 100 students sample has been taken, and to correlate between weights and heights of those 100 students, and on that basis correlation has been computed. It gave 0.7625, that is high degree positive correlation between height and weights of the students of a school. So this 7625 has been applied to whole school as there is high degree positive correlation between weights and heights of all the students in the school. Depending upon 100 students only, 100 students sample only. We are asked, within what limits does it hold good for entire school? Total school ಗೆ ಯಾವ ಲಿಮಿಟ್ ಇರುತ್ತೆ ಕಂಡುಹಿಡಿಯಿರಿ ಅಂತ. So if another sample of 100 students are taken, what will be the answer? At what range, what limits the answer will fall? That we have to compute. That means simply you have to compute limits, lower limit and upper limit within which correlation coefficient falls. Same procedure. First calculate PE. Formula 0.6745 into 1 minus R square whole divided by 0 square root of n. So 0.6745 is same into 1 minus 0.7625 whole square divided by square root of 100. So simplify this, you will get 1 minus 0.5814 divided by 100 square root of 100 means 10. So find out, simplify, and you will get the answer 0.02823. PE 0.02823. Let us find out limits R minus PE and R plus PE. Okay, pause this, and those who are slow, you can write them in your notes. Okay, limits R plus PE and R minus PE. R means 0.7625 plus 0.02823, and R means 0.7625 minus 0.02823. Find out 0.79073 and 0.73427. Okay, lower limit is the correlation coefficient of entire school will fall between 0.73427 and 0.79073. This is the answer. Okay, lower limit and upper limit. Okay, I hope you are understanding the problems. Worked problem, find probable error when the correlation coefficient is 0.75 and number of pairs of items is 36. Interpret R is the question. Find probable error when correlation coefficient is 0.75 and number of pairs given are 36. Then we have to interpret R. First, let us find out probable error. Probable error 0.6745 into 1 minus R square divided by square root of n. Substitute the values 0.6745 into 1 minus 0.75 whole square divided by square root of n. Simplify that. 0.6745 into 1 minus 0.75 into 0.75. So it will be, don't take minus into the square option, minus into minus plus, it will not like that, it will not be like that. So within bracket it is plus 0.75 into plus 0.75, therefore it will be plus 0.5625 plus into minus minus divided by 36 square means the square root of 36 means 6. Simplify this, 0.6745 into 0.4375 divided by 6. Again simplify this, 0.6745 into 0.027292. Answer will be PE is 0.04918. Okay, we have to interpret R. So for interpretation of R, we have to find out 6 times of PE. Then we have to compare that 6 times of PE with R. If it is lesser than R, 6 PE, R is lesser than 6 PE, we should say R is insignificant. If R is greater than 6 PE, we should say R is significant. Let us verify it. Interpretation of R, 6 PE equals to 6 into 0.04918. It will be 0.2951. So R is 0.75. Correlation coefficient to 0.75, but 6 PE is 0.2951. R is greater than this 6 PE. 0.75 is bigger number than 0.2951. Therefore, R is greater than 6 PE. Therefore, R is significant. We can depend upon the value of correlation coefficient. Okay. So this is the interpretation. You have to find out 6 PE, 6 into probable error. If that value 6 into PE, that value is more lesser than R, that means R is greater than 6 PE, you should say R is significant. If it is reverse, you should say R is insignificant. Understand this, memorize. Next problem. Next problem, full-fledged problem on probable error and correlation coefficient. Both you have to calculate. The following data relates to the percentage of failures in the 10th standard examination of some state. Age of candidates is given 13, 14, 15, 16, 17, 18, 19, 20, 21. Percentage of failures, total percentage. How many students of 13 years age have taken 10th exam? We don't know. All those things the data is not given, but 13 years age students, 39% of such students have failed in that examination. For like that 40, 43, 34, 36, 39, 48, 47, 52 is given. Find whether there is any correlation between age and failure in the examination. So this is the first question. We have to find out correlation coefficient between age of candidates and percentage of failures, and say any relation between quantitative relation between age and failure. Then interpret the result by finding the probable error. We have to interpret the correlation coefficient by using probable error also. Let us try this solution. Next slide. You have calculated correlation coefficient in previous sessions. I am not presenting here detailed solution. The detailed solution have been already explained in previous sessions. You may observe them. So X value, age of candidates has been taken as X and failure has been taken as Y. So X bar direct method is used. X bar is whole number 17, Y bar is 42. Therefore, whole numbers we are getting. Therefore, I have used the actual mean method. This is the solution for table related to correlation coefficient. Okay. Those who are slow, pause this video and write down. Okay, you may solve this problem using assumed mean method, indirect method. Okay, that is your wish. You can also solve this using assumed mean method. Okay, after calculating required information through table, let us substitute them into the formula. R equals to sigma xy divided by root sigma x square into sigma y square. Substitute the values. 88 divided by square root of 60 into 284 equals to 88 divided by 130.537. Simplify that 60 into 284 and square root them. Okay, answer is 0.6741. There is moderate degree positive correlation between age and percentage of failure of candidates. This is about correlation, calculation of correlation. We have to interpret this correlation using probable error. Therefore, let us do it. Find out PE first. PE equals to 0.6745 into 1 minus r square divided by square root of n. Substitute the values. 0.6745 remains same. 1 minus r means we have calculated 0.6741 into 0.6741, that is 0.6741 square divided by square root of 9. 9 pairs are given, observe in the problem. So simplifying this, we get 0.6745 into 1 minus 0.4544 divided by square root of 9 means 3. Simplify this. 0.6745 into 0.5456 divided by 3 equals to 0.6745 into 0.18186 equals to 0.1227. This is probable error, value of probable error. Using this, we have to interpret R. Therefore, to interpret R, we need 6 PE, 6 into probable error. Let us find out this. Interpretation of R, 6 PE equals to 6 into 0.1227 PE. PE value is 1227, 0.1227 equals to 0.7362. Observe this. 6 PE is 0.7362, whereas R value is 0.6741. So 0.6741 is lesser than this 0.7362. Therefore, R is insignificant, not significant. We need not depend. We cannot rely on the value of R in this case. Age of students and failure may not be the correlation coefficient between age of students, candidates, and the percentage of failure cannot be dependable. So there is some error, there is some lacuna, there are some limitations in the given data. So that is our decision. Okay, so that's like that we have to interpret. Next, practice yourself. You work out this on your own. Find Carl Pearson's coefficient of correlation from the following series of marks secured by 10 students in a class test in mathematics subject and statistics subject. So data is given. Also calculate probable error and limits within which the population correlation coefficient may be expected to lie. Hence comment. So you have to calculate correlation coefficient, probable error, limits, lower limit and upper limit, and 6 PE, and on that basis you have to give your interpretation. So all the things you have to work out here. Answers are given. R is 0.90312. There is high degree positive correlation. We have to write this. Then PE. Answer is 0.03932. 6 PE you have to compute. R is highly significant is the final answer. Okay. Like this you have to. Limits also you have to compute. So population coefficient may fall between 0.8638 and 0.9424. These are the limits. So all the things you have to calculate, work out, practice yourself in your home, okay, by writing this. Next one, similarly practice this one also in your home. So answers are given minus 0.97505. So the same answer is saying negative correlation, high degree negative correlation. If required, it is asked probable error between two series also you have to calculate. Therefore probable error is 0.010501. If required, you can find out limits and 6 PE and say R is not significant. The answer is R is not significant. You can practice on your own. Okay. So I think that is the end of session today. You learn problems on correlation coefficient and probable error. We will work out some more problems on correlation problem. Miscellaneous problems are there. So in the next session we will be working out some miscellaneous problems on correlation coefficient. Okay, thank you.